Let's do a sound check. Yeah, we're good to go. Wow, super quiet today. Strike? No, I don't do private lessons, unfortunately. But tell you what, if nobody else is here, ask questions and I'm happy to answer away. All right. Alright guys, so if you guys are joining us today, we have, I don't know, might give like a few minutes if if you need any help with any kind of questions, just drop it on the chat, or you can actually send it to my email as well. I'm happy to work through. Strike, unfortunately I can't help with the PE assignment. I have put it down as level 2. I mean, if there's like no level 2s here, and if you've guys got like level 1 or level 3s that are here, that's fine as well. So this is just like some free time to ask questions. And if it's not level 2 focused, then that's all right. I'm happy to work with whoever that's actually on at the moment. So I'm here going to be here till about 9 p.m. Yeah, sorry, Strike. Like if you need some help with level 2, yeah, feel free to ask. Eric, not sure, man. Like I always, it depends on the year, man. Like sometimes it's like complex numbers is like super easy, and then sometimes, you know, I don't know. It just depends on the year. I wish I could answer that question to you. Unfortunately, I don't think I can answer it, because they just mix it all up. I'll keep my email open. This is Amy H. Your name rings a bell. I think you did ask a question. Am I correct? All right. Yeah, I remember that question. Which question was this? Hey, Ash. This was question 3C2. All right, let me have a look at my notes, because it is here somewhere. So level 2 exam questions, exam papers, level 2 algebra. That was question 3C2. Let's go have a look, because I know I did it a while back. So this is 3C. Wait, did you say 3C2? I can't actually see a 3C2. Can only see 3C1. Hey Jason, welcome back, man. Welcome back. Equal to 0 or less than 0. I'm trying to think which. Is this question 3? Yeah, this is question 3. Amy, could you tell me which part of that question it is? 3C2 or 3D2? Park, non-zero constant means that you're, well, non-zero. So C value is not equal to 0. That's what it would mean. So when you like, depending on the situation, like if you integrate, Amy, I'm gonna come back to you. Just chuck, where are we at? Where did I put it? Level 2. So non-zero constant. It's about Zara selling zips. Okay, I'll have a look at it. Say for example, if you do anti-differentiation of x, you're gonna get x squared over 2 plus c. Now if they say that it's a non-zero constant, generally I would say that c is anything but 0. Zara selling zips. What the? Where is this question and why can't I remember? There is no Zara. Where is Zara selling zips? Oh, 2020 algebra paper. Sorry, I'm looking at 2021. No wonder. Okay, so 2020 algebra paper is there. That would explain it. I was like, what is happening here? 3C2. Zips. Here we go. So that's 3C2. Myung-kyo, hopefully I answered you that question. I have to remember this question because I did it a while ago. Alright, so what did you write there? You mentioned that the discriminant must be positive, but why can't it be equal to or less than 0? Now, when it comes to what do we got here? Realize it's not every possible turnover. Sorry, I'm just having a look through my old notes. Oh, I've actually got it here. Discriminant has to be positive. What's the original question? So we got turnover is price, blah blah blah. 60 squares that. Not every whole number is possible turnover. Generally speaking, when we look at discriminant, right? If we want to find discriminant has to be positive. It can't equal to 0 because if discriminant equals to 0, then generally it means that there's only like one answer to it, and I'm guessing in this case you're looking for 2 answers. Possible turnover. Number of price times zip sold, so turnover is flip. So that gives me positive and whole. Man, this was such an old question. Like, I need to actually go back and look through my working properly again. A rational number has to be a square number. D is an integer. D is positive. Yeah, I hear what you're saying. Like, how do I know there's 2 answers? Let me just go back to my other notes and just have a look. 9-1. 9-1-2-6-1. It's one of those weird questions. Examination paper. 3C2 was my notes. So 3C2 is find possible turnover. So if it's possible turnover, you're gonna have So that's equal to k. Yep. So if you want to have possible turnover, it has to be above 0. The solutions have to be above 0, which means, right. So that kind of makes sense now. How do I know that there's two solutions for this? Because remember that when you have a parabola, right? I'm going to go back to my thing, my other book, so I can show you there. So in that question that we were looking at before, what you had was, remember that we had turnover, right? Now turnover means the turnover has to be positive. And that graph that we were looking at was actually a parabola. So if you have a parabola, you've got basically something like this happening, where everything above when the line of y equals to 0, that's like the flat line is like y is equal to 0. Everything above it is positive, and everything below is negative. So if we were to think about it like that, then your positive turnover actually happens along these points right here, right? So that means you're getting I guess a profit. And on this side, you've actually got a negative turnover happening here in this zone. And if you look at just this point right here, where those 2 points are, that's where you're kind of like breaking even. So for you to actually have a positive turnover, you're actually looking at the yellow zone, right? That's where discriminant has to be positive. So if you think about it like that, in the yellow zone, the discriminant is positive, which means it's greater than 0. If there is like where it's meeting, it's equal to 0 because you got like 2 solutions. And then in the negative zone, it's kind of think about it as there's going to be no solutions, so you're not going to end up with any kind of profit in that space. Because imagine if no, I think I'm explaining that incorrectly. Let me try this again. Hang on, give me a second. Let me try this again. What I mean by is that shape that we had was a parabola. So normally when you do this, you're going to have 2 solutions, right? You can have 2 solutions, you can have no solution, and you've got a single solution. Let's try that again. So when you actually have positive turnover, this is positive turnover. Here you've got positive turnover, but you're also hitting 0 there. So that's where the discriminant is actually equal to 0. Here you're getting positive turnover, and you're also getting some situations where it's negative. So you have to go, D has to be greater than 0, because the discriminant has got to be positive for your whole graph to be above that 0 line, so that you actually get maximum positive turnover. That's possibly the terrible way of explaining it, but let me know if you've got any questions. I mean, like, I'm happy to kind of answer through them, so it's not a problem. The roots of the quadratic equation is real. Yes, user 1234. You're looking at how do I put this? Sometimes you can actually have complex. Two solutions. Yeah, you're right. Yeah, you're right. I don't know what I'm doing here. Give me a second. Let me just. 2021 notes. I'm getting mixed up here with something. Yeah, you're right. So what's happening here? So let's go back to the original question then. Roots of the quadratic equation is real. So like, I think if you're dealing with complex numbers, you might get like in as part of your solution. So just to keep that in mind. Okay, let's break this down then. Let's go back to original discriminants, right? So if we look at original discriminants, then that is when discriminant is positive. That is when discriminant is equal to 0. That is when discriminant is less than 0. This is, I think what we're getting confused here is with the graph and the discriminant itself. So for the graph would look, no, that's still correct. This question is pissing me off now. Turnover is Minkyo. We'll go through that in a sec. I just want to answer this question for Amy. Why D has to be positive? So, sorry, I'm just going to share my old notes with you. Again, we're going to go back to it. Give me a second, Just start with camera. Okay, here we go. All right, so what do we have here? With this question, Zara notices a higher price of the zip. Fewer zips are sold. Let's actually have a look at what this graph actually looks like. So this graph is minus 60 squared plus 187D plus 6D. Go to Desmos. Maybe I can explain it through this way. What was it? Minus 60 squared plus 187D plus 60. Okay, so there is my ugly looking parabola. I just want to change this a little bit to maybe 100. So you can see it a little bit better. Okay. So that's the original equation, which we got from here. So D is 31.48.3. So there's my two values where I need a solution balance and never makes exactly 445 in a day. Yeah. So it never makes 445 in a day, so it's not possible. And I think this is where we got up to. Not every whole number is possible for a day. Use algebra find. Okay, what I'm gonna do, Amy, what I'm gonna do is I'll probably just need to have a look at, I'm gonna have a look at that question again, because it's just off the top of my head, I can't remember what I actually talked about during that session. So no, you were right. Like I got carried away with parabolas being above and discriminants. I got mixed up. So what happens when you don't do level 2 maths for like 6 months, but rusty at the moment. So Amy, just leave that with me. What I'll do is I'll have a look through that question again, and I'll get back to you on, I think you put a comment on that video, so I'll actually get back to you on that, if that's all right. Sorry, man. I wish I could just pull it out of my head right now, but it might come back to me like at 2 o'clock tonight when I'm like sitting there wondering what happened to be there. Welcome, Leon. Yeah, it's good to Yeah, it's kind of just doing things slowly at the moment. Zia, I'm just kind of doing open at the moment, so if you have any particular questions, you can throw it out there. Ming Kyo, so differentiation, when you talk about calculus, right, there's two things that you end up doing. What you have is you've got your original function. So let's say you have like a parabola that's like x squared. So this is like y equals x squared. You differentiate it. So when you differentiate it, you bring the power to the front and you reduce the power by 1. So it becomes like y equals 2x plus 2x to the power of 1. Now, what happens is that this is now like a straight line, right? This is basically differentiation. Differentiation is like you're going and having a look at every one of these points along the parabola, and you're trying to figure out what is the gradient there. So if I was to show you, like notice like this, you know, you got a negative gradient, negative, 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 and at some point it's going to become 0 because it's flat, and then it's going to start going positive, positive, positive like that. So if I was to actually draw this in a graph format, so if that's the parabola, then you're going to end up with something like this. So where this point and this, so say if this is like, I don't know, 4 for example, then this point would be 4. Because the gradient when x equals to 4 happens to be 0. And before that, it's all negative. So notice how the ruler is actually pointing down. And because it's pointing down, it's going to be all negative gradient up to the turning point. So that's why it's negative here. And after 4, the gradient's all positive. That's why it's actually positive. One more thing to notice is in this graph, we actually have the y value. In this graph, we don't actually have the y value, but we have y dash, which is actually the gradient at that point. All right, so that's what differentiation is. Integration is pretty much the same concept, except going backwards. So if I have a, I don't know, like something like this, a straight line going like this, and this is the graph, let's just say for namesake, this is minus 3x. Then what happens is we've got a turning point along this line. So let's say again, this is maybe 5, for example. Along here is 5. What's happening here is the gradient is actually negative, positive first, and then after that it's actually in the negative zone. So your parabola is actually going to look kind of like upside down. All right, so if you have a look at it, so along here the gradient is positive, 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 and then we get to when x equals to 5, the gradient is 0, and then the gradient starts becoming minus again. So how do we do that in terms of like if we have an equation? What you do is you would write this as negative 3x. What you do is you add 1 to the power. So right now it's 1. So we add 1 to the power and divide by the new power. So what ends up happening is you're actually getting an equation that's negative 3x squared over 2. And the thing that we need to add is the constant. All right. So pretty much in like the most quickest way possible to explain to you is differentiation is going from the graph to its gradient function, and then integration is like going from the gradient function back to the graph. Hopefully that helped you there, Ming Kyo Park. But I know that I'm still working on some videos for calculus level 2. I think I've done up to like I'm going to be doing optimization soon, and after that it's integration. So yeah, so we'll get to that. Differentiation questions. Malika, do you have like a particular question in mind? You know, if you do have one, like either drop it on, you can actually just give me what type of question you guys want, and I'm happy to kind of like work it through. Let's have a look. Oh, nada. Oh, no worries, Leon. How's uni going? What are you doing in uni? That's the most important thing. Have I done a video on arithmetic sequence? No, I've not actually done arithmetic sequence. Arithmetic sequence, I think, what's the formula? Is it like, can you type in, let me just have a look. Is it Tn equals A plus N minus 1D? I think, geez, that's like year 12, back like ages ago. Oh yeah, got your message, Malika. Give me a second. Which email is? Oh man, upside down questions. Alright, this is going to be fun. Give me a second, Malika. I'm just going to try and see if I can sync that file. Where is it? Level 2022. Paste picture. Rotate. Come on, sync. I'm just grabbing the questions, Malika. Give me a second, eh? Where are we at? See, my syncing just takes so long, but while that's trying to sync, it might magically appear here somewhere. Where is our next tab? So, Strike, I'm going to answer your question while my thing tries to sync up here. Sync this notebook. Come on, man. Sync. What was I going to say? Oh, here we go. Pictures are coming. So with arithmetic sequence, let me kind of work through here. I'll answer your question and then we'll actually go to Malika's question. Arithmetic sequence. I think the formula that you guys get given is I don't know. This is off my Tn A plus N minus 1D. I think that's the formula that you'd be working with, Strike. So a really good kind of tip is to look at the numbers themselves to see whether if it's arithmetic or geometry. The way you do that is you look at the numbers and you find out whether it's actually going up by ratio or whether it's actually going by a difference. All right, so what do I mean by that? So if I say I'm going to throw in a couple of numbers here, so 7, 10, 13, not 15, what is it, 16, and then if I give you another one which is like 7, 10, 6, 16, I don't know, I'm just kind of making stuff up here, like let me just, I don't know if this is going to work, but like we're going to try it. 16, what else? 3, 6, 12, 28. Yeah. So it's to have a look at the numbers, what's happening, right? Now, like in this first one here, you can kind of see everything is always like going up by 3. In this one, it's like plus 3, plus 6, and we've got plus 12, for example. So that's slightly different. So you can kind of straight away see that, okay, the bottom one is not arithmetic because the numbers are not going up by the same kind of like number it's going up. So here what we're going to do is we're going to say that D is equal to 3 because D stands for difference. So difference is positive 3. A is like, if you think about it like this, you forget it, right? A is the first letter of the alphabet, which means A in this case is like the first number in the series. So we're going to put down A as 7. N is like whichever number you're looking for. So for example, if I think about it like this, N is 1, 2, 3, 4, so on. So what's the, I want to look for like the 8th number in the series. I'll actually put it as T8. So then I'd have T8 as 7 plus 7 minus 1 times 3. So that's going to be 7 plus 6 times 3. 18 and 7 is 25. Now if I was to carry on with this, 16, 19, 22, and 25. What have I made a mistake with? 7, 1, 2, 3, 16, 19, 22, 25. What have I made a mistake? Oh, 8. Sorry, there we go. That should be 8, not 7. It's going too fast. 21, 28. So as you can see, this is the 8th term in this series. Yeah, so if you know, like, the main important part about sequence and series is actually recognizing, first off, whether it's arithmetic or geometric. Once you do that, try and figure out like which formula you're going to try and use. Are you looking for the sum? Are you looking for the term? And then after that, you should pretty much be like, okay, yeah, this is the formula I'm going to use to try and work this out. Cool. Arithmetic. Malika, I've got your question. What equations do we need to know for a parabola like vertex form for level 2 algebra? User 1, 2, 3, 4. For I would say like vertex form is quite handy, to be honest. And remember, like, if you ever forget it, right, like, you always use your calculator, man. Like, in your calculator you've got your not under graph mode, but if you go under conics mode, you can actually pick up that right there. So that's like your vertex form equation. So if you forget how to do the vertex form, you just go to the calculator and grab that equation from there, and you should be able to work it out. Alternatively, if you've got 3 points, you could always go into graph mode, and you can actually put your 3 points in there to get your equation as ax squared plus bx plus c. So that's fine as well. Oh, yep. Amy, we'll actually do that question right after I answer Malika's question, all right? Leon, yeah, it's yeah, biomed. Good luck, man. Good luck. User 1, 2, 3, 4. I'm actually going to be honest with you. Like, algebra has a bit more content. Calculus is a bit straightforward to kind of. Ultimately, it's what you want, right? Like, so if you're trying to get, like, if you want to do engineering or like any kind of like architecture or anything like that, you know, you want to make sure that you're confident with algebra and calculus, both of them. But if you're just doing it for the credits, then I would say calculus is probably slightly easier than algebra at level 2, just because, you know, sometimes you differentiate and you can kind of get away with grades in it. Then again, I have actually worked with kids on particular algebra skills where they kind of know what type of questions come in and pretty much nail it after that point, because like with algebra you get, like, you know, it's a lot easier to answer merit questions, and if you make a mistake you still get them achieved. So yeah, it really depends on what your aim is. If you're doing engineering, then I would say you better buckle up and get on to the both of those two. All right, let's have a look at this question for who is it, Malika? Sorry, I know you've been sending that question a while ago. What is that part? What problem makes it? Oh, right. So this is the rest of the question. I actually thought this was 2 questions. Calculate the height of the rope above the where it is attached to the bollard, and what the. Okay, so if you guys look at this first question here, right, I'm hoping that you can actually see it, but I'm going to try and see if I can blow it up a little bit. There we go. Lovely that they've actually put in they've given us an equation, and they've also given us a picture. So we're going to work out the height. The height is y value, so that means we just put x is equal to 0, x equals to 7. Because if you think about it like this, and we're going to go with sea level, I guess, is, where's the vertical distance? Height is the rope above the water. So right now we can actually draw that as your x-axis and your y-axis, which means you substitute 0 and 7. So when x equals to 0, y is equal to 4.8. When x equals to 7, y is equal to 0.2 times 7 squared minus 1.67 plus 4.8, whatever that is, all right? Looking at the second part of question, so this is part B. it's asking you to find differentiation dy dx, right? Now, most of your calculus questions, what happens is that, you get an equation. If you want to find maximum or minimum, you've got to differentiate it and put it equal to 0. So what we're going to do is, in this case, we're going to differentiate it. So because we've got 0.2x squared minus 1.6x plus 4.8, we're going to differentiate it, which is the same thing as saying dy dx. Now, here's a little tip for you guys. When you differentiate a function, like say for example y, when you differentiate it, you can write it as dy dx. You can also write it as y dash. Sometimes you can also write it as f dash of x. All right, so there's just lots of different ways of writing it, but what they generally mean is like when you have y, you can write it as dy dx or y dash, and generally when you have f of x, you write it as f dash of x. So in this case, we're going to get dy dx, which is just differentiation of y. So we do 2 times 0.2, which is 0.4. X to the power of 2 minus 1 is just 1, minus 1.6. Okay, great. I'll tell you why we're going to put this equal to 0, all right? Now remember when I did this previously with these two examples for calculus with differentiation and integration. Remember when I said this, like, so this is when your gradient is negative. Like, look at the ruler. The ruler is going down. And then on this side, it's actually positive because the ruler is going up. Everything is rising. But the turning point is right there, right? Along there, the ruler is actually flat. I'm trying to get a flat, but you get the idea, right? Right there is the gradient is actually 0. So whenever you have a turning point, so when you have like a parabola like this case, your turning point happens to be right there or right there. So those 2 points that I've kind of pointed out with that pink highlighter, those are turning points. That's when the gradient is equal to 0. So generally, if you look at like a shape of a rocket, when a rocket goes up in the air and then it comes down, so it's that turning point is the maximum distance it can actually go. Or another example would be like if you look at a yo-yo, you drop the yo-yo, it goes to a certain point and then it comes back up. That bottom point is where the turning point is happening. That's also where the minimum, that's the minimum height above the ground it's going to go up to. So if you look at this question here, you can kind of straight away see that this point right there is where your turning point is happening, right? That's when the slope is actually like before that point, your rope is kind of coming down. After that point, the rope is kind of like going up. So if you think about it like this, the gradient is going from like negative. So I'm trying to see I can't do this. It's like, hang on. Is that, yeah, that's right. I hope that looks right. So negative, and then it's going up this way to positive. Negative, positive. Yeah, right. My camera's flipped at the moment. But look, it doesn't matter. What matters is that we just differentiated, put it equal to 0. Because anytime you want to find a maximum or minimum, you always differentiate the equation. Whatever the equation is, you got to differentiate it, put it equal to 0, and you're pretty much good to go. All right? Because if you look at the question, right, like they say, write an expression for dy dx. We've done that. We've actually done part B right there. So if we go to part C says calculate the distance between the water and the rope at its lowest point. So this is what we kind of need to do for part C. What we need to figure out is what's the x value when the lowest point actually happens. All right, so the way we're going to do that is we differentiated it. We've got 0.4x minus 1.6. We're going to put this equal to 0, rearrange and solve it. So we're going to get 0.4x equals, now negative 1.6, switch it over to the other side, is positive 1.6, which means we're going to get x is 1.6 divided by 0.4. So we're going to get x is equal to 4. Now, here's the important thing. What we've just calculated is actually the x distance of where the lowest point is. All right. So in other words, we've not actually found the the distance between the water and the rope at all. What we've just discovered is that this point right there is equal to 4. So now we take this 4 and we put it back in the original equation to get the height that the rope is above the water. So if you think about it like this, so this is the graph right now. Here's my rope, kind of looking like this. Okay, it's a rough idea. So this is where the turning point is happening, and we've just discovered that the x value is equal to 4. But what we need to figure out is what is the y value. So we're going to go back to the equation. Y is equal to 0.2x squared minus 1.6x plus 4.8. And we're going to substitute 4 wherever x is. And a really good thing to kind of notice is that if your answer has to be above less than 4.8, because remember, if we go back right there, that actually told us that this value up here is 4.8. So your final answer has to be between 0 and 4.8. So if you get anything above 4.8, then you've done something wrong. If you get a negative value, you've done something wrong, because you can look at this graph. I mean, you look at this graph and you can tell straight away, okay, 0 is there, 4.8 is there. Your answer has to be between 0 and 4.8. So we're going to go into the calculator, just chuck it all real quickly. So we've got 0.2 times 16 minus 1.6 times 4 and plus 4.8. So we got 1.6. So this is basically telling us that this 1.6 is actually right there, and we actually use the 4 to figure out what the height above the water is. So for, I think we just worked out D part 1, which is equal to how high would the water level have to rise for the capstone to be level. Oh no, wait. You know, I think we just did C at the moment. Right. Does that kind of help Malika so far with that question? Do you still want me to carry on with the rest of it, or what would you like me to do? Sorry, I'm just going to grab some water. You let me know what you need me to do. So do you want me to do the rest of the question, or do you have any other different questions? What are we looking at, Banana? What topic are we looking at? Because I'm supposed to be running one similar one on Thursday. How high would the water level have to rise for the capstone? All right, Malika, so I'll wait for Bananas. What was I gonna say? I guess we kind of need the answer for that one, so I'm gonna go back to question A, and I need to figure out what the height is. So x equals to 7, so that means I gotta go 0. Wrong area. 49 is what I'm looking at. Hang on. 7 is 49. 4 is 7. Okay, so 3.4 is this value right there. I'm going to kind of draw it for you, Malika, so you can kind of see what's happening there. So when x equals to 7, you can kind of see that the height is 3.4. So the question is, how high would the water level have to rise for the capstone to be level horizontally with the bollard? Well, if you look at it, it's like 1.4 meters, that's the difference. So I would say, because right now that, what is it, the capstan is right here at 3.4 meters. And if it needs to be level at 4.8, the difference between 4.8 and 3.4 is 1.4 meters. So that's what I'm going to kind of say for that. Oh, well, would it? Yeah, because, no, would it? Yes, it would. 3.4. Yeah, nothing would change. Let me know if the Malika, if the answer is 1.4 for that, please. When the water level has risen by the distance in part 1, the height of the rope can be modeled by ax minus b squared. Ugh, ax minus b squared. Why would you do that? That's quite annoying. Calculate the values of a and b. Well, the thing is, it would change. Malika, can you also just maybe tell, where is this? Yeah, so I is 1.4. Yeah, thanks, Malika. Yeah, it is 1.4. A is 0.527, B is... how did you get that? When the water level has risen by the distance in part 1, the height of the rope above the model can be by this parabola. Okay, alright. What does that mean? Ax minus b squared. I'm trying to think of how and rope height above the rope, but I only have 2 points. Okay, let's try this out. I mean, like, I'm gonna kind of take a wild guess at this one, but just to see what it does. So for the new graph here, so once it's risen, we're gonna get something like this. So this is gonna be 4.8, and this is gonna be 7, right? I don't get to ax minus b, a minus b squared. This is the part I'm not comfortable with. How do you put that as a complete the square? Are we assuming that it's halfway between that? Zero 0.2. If the water has risen by 1.4, then it's no longer 4.8. It'll be 3.4 and 3.4. And if it's risen by 1.4, was its lowest point was already 1.6. So do we then assume that it's now 0.2? But then if we do that, I've never seen a format like this, ax minus b squared. What I might do, Malika, is I'm just going to try something here. I might put this in graph just to see what we can actually get. So to do this, I'm going to go to step mode, and I'm going to put all of these points. So I've got 0, 3.5, and 7. And then I'm going to go to the next slot. So we got 3.4, 0.2, and 3.4. Unless, wait, when the water level is part 1. See, the only way that's going to work is variable, no, exit, graph 1, calc. I'm just going to try one more thing here, guys. Just give me a second here. If I change this to 0, no, that's not going to work. At 3.5, then it's going to be 4.8. Give me a second. I don't think I'm understanding the question correctly. The height of the rope, how can we model? When the water level has risen by part 1, what do we did? That's 1.6. So if it's 1.6, the new height would be 3. No, he said 1.4 is what it's going to rise by. It's 3.4. That makes sense. Ax minus b is, what's that value that you gave me? 0.527, 1.844. Ax minus b. Give me a second. I'm just going to chuck it on. What's it? Ax minus b, ax minus b squared. Add all. What do we got? 527,184. Just trying to understand what they're doing here. Okay. So why is this not working then? 3.50. Why is it not working? Oh, it will work because it's expanding. Because it gives an ax squared minus bx plus c. It's the wrong one. Okay. I get it what's happening here. Cool. Let's go back here. Sorry guys, just trying to understand what the question's actually asking first, and then trying to figure out how to actually get to the answer. So let's go back to the question part 2. Right now it says when the water level has risen by the distance in part 1. Now originally this was at 4.8. Now it's risen by 1.4 meters. Yeah, it's risen by 1.4 meters. This is part 1 that we did right here. So if it's risen by 1.4 meters, then this is no longer 4.8 meters. It's going to be 3.4 meters. And the graph is actually going to look like this, where it's going to touch the ground and going to come back here. Now, this point right here is 3.50. All right. So now it actually says that the parabola's equation is y equals bracket ax minus b squared. Now we've got the points. Our points are 3.50. So we're going to use that first. But that's not really going to help us because it's going to kind of make things a bit weird. What we're going to do is we're going to use the 0, 3.4 first, which means we're going to put 0 equals a times 3.4 minus b squared. So here we're going to get 0 is equal to 3.4a minus b. I hope will this work out? Square root of that squared, but then we can take square root of both sides, which is going to give 0 is equal to 3.4a minus b. So we can say that 3.4a equals to b. So that's the first equation. The second equation, we got to use the same one again, but this time we're going to use 3.5. What am I doing? Oh my god, what am I doing? Man, messy. Let's try that again. 3.4 equals a times 0 minus b squared. Sorry guys. So 3.4 equals negative b squared, because a times 0 is 0. 3.4 equals to b squared, and b is equal to square root of 3.4. So what is that? I'm like, what am I doing today? Rusty times. All right, there we go. That's 1.844. Then we've got 3.50, so we're going to put 0 is equal to a times 3.5 minus b, which is 1.844 squared. So 0 is equal to 3.5a minus 1.844. And because we take square root on both sides, we're going to get 0 is equal to 3.5a minus 1.844. And then 3.5a equals to 1.844. A is equal to 1.844 divided by 3.5. So that is what we're looking at. Divided by 3.5 gives me 0.526. What did she give me? Yeah, 527. Yeah, a bit of a annoying calculus question, because there's a lot of you've actually got to come up with the equation of the parabola there, but there we go. That's how we get that done, Malika. So if you still have any questions, just flick a message. All right, time to answer some questions here. Bera, do you do level 2? I don't think there's a level 2 scholarship paper. I mean, there is a level 3 scholarship, but I've just never had the what do you call it, the patience to try and do level 3. Banana, probably any of the 3 topics. Now, what am I going to say? Complex numbers, I've got like some really good stuff that I did back in 2020, like really long videos, but like, yes, thank you, Amy. We're going to do that next. Sorry, I'll just put that here. Kind of lost track of it. A over x plus 3 minus b over x plus 2 equals 3x minus 2 over x plus 3 x plus 2. Yeah, we're gonna do that. Sorry, Amy just kind of got sidetracked with that. What was I gonna say, Banana? Like, yeah, there's a playlist called Mathemic Level 3. If you have a look at that, you can. That's pretty much covers complex numbers, and I'm happy to do something like that for differentiation. It just takes like I think it takes about 12 hours, and you know, I'm happy to do it. Just need to know if it's like a whole bunch of people asking different questions, it's kind of hard. But if you guys want that, that's something that I can actually do as well. Myung Kyo, yeah, I agree, man. 2020 paper, I had to look through even right now, like going back and looking at it. Normally when I look at an exam paper, I kind of remember doing it, and I'm like, yep, okay, I kind of remember. But 2020 was a weird paper. Like I remember talking to some of the kids, and I was like, man, considering the year that you guys, some of the kids had in 2020, it was hard work to do that paper. All right, what I'll do is I'll answer. Why can't I find your question, Stacy? Oh yeah, got a request there. Okay, so what I'll do, Stacy, I'm gonna copy that and see if I can put this somewhere in my paper so that it kind of pops through while we work at another question. Where is this? Oh, it's down there. Okay, where should I put this question? Paste. Give me a second. I'm just kind of like putting the question up there. Stacy, we're going to come to that question after I do this question here. So hopefully this just syncs up. I'm just going to try and sync it again. Sync. Cool. So while that's happening, this question here. Okay. So Amy, what you want to be doing with this question is pretty much cross multiplication expanding the brackets, and then kind of matching things up. All right. So what do I mean by that? Let's actually, I see whenever you guys do fractions, I have the habit of kind of like spacing them out a little bit so that I can actually kind of multiply it with the other remaining fractions. All right. So what do I mean by that? Just be patient. I'll show you guys how to do this. A lot of people end up doing like cross multiplication, which can be great, but when you have like quadratics in the denominator, it can get very messy very quickly. So have a look at this. On your denominator on the left hand side, you got x plus 3 and x plus 2. All right. Now if you want to have the same denominator, you've actually got to multiply the denominator here by x plus 2, but you also do that for the numerator. Likewise, you repeat the step for the other one. You got to multiply by x plus 3 and x plus 3 in the numerator. Why? Because x plus 3 is here, so you got to multiply for the other fraction with x plus 3 and x plus 3. X plus 2 is here on the left-hand side, sorry, right-hand side fraction. So for the left-hand side fraction, you got to multiply by both of them. Because when you do that, then what happens is both of your denominators end up being the same. Okay, so now all we're going to look at is we're only going to be interested in the numerator. We don't care about the denominator, because the denominator, we've kind of matched the denominators, right? So in the numerator, what we're going to do is a x plus 2 minus b times x plus 3 equals to 3x minus 2. Now here's the important thing: expand the brackets, match the x to the x's, match the numbers to the numbers, and you're good to go. So what do I mean by that? We are going to expand these brackets here. So when we expand them, we're going to get ax plus 2a minus bx minus 3b equals to 3x minus 2. Now, when you get a situation like this, it's really important to understand that you've got ax minus bx equals to 3x. All right. Then your second lot of equation that you have is 2a minus 3b equals to minus 2. Now the reason we actually do this is because what we're trying to do is collect all the x's together, and then all the things without x's, we're going to collect them together. So in this situation, if you look at it, ax bx is equal to 3x. So ax minus bx is equal to 3x. So that's actually going to be our first equation that we're going to write down. Ax minus bx equals 3x. But the other thing also is we don't need to worry about the x's, right? Because think about it like this. If I tell you 7x plus 3x, or 7x minus 3x equals to 4x. Now this is the same thing as saying 7 take away 3 equals to 4. So based on that idea, I can rewrite this as a minus b equals to 3, because x is a common factor in all of them. We don't really care about it. All we care about is the letters in front and what it actually equals. So this is the x part. Now if you look at the second part, that's 2a minus 3b equals minus 2. So that's all from here. So what we ended up with, we've actually got a set of simultaneous equations. We've got two sets of equations, two unknowns. So what we can do is we can go straight into the calculator and we can actually put it in our equations. Where is it? Go into equations. We're going to go simultaneous. Number of unknowns is 2. So we've got 2 minus 3 minus 2. And then we've got 1 minus 1 and 3. And when we click solve, we've got a, which equals to, that's the first letter, which equals to 11. And b, which is the second letter, which equals to 8. So, Amy, hopefully that kind of helped with that question. Let me know if you have any problems with that. Grub, at the moment, yeah, we're doing all level 2 questions at the moment, mate. So really important with that type of question, right? Like the key thing is what I've done with that highlighting part right here, with kind of multiplying it with the factors of it more than the doing like cross multiplication. Because when you do cross multiplication with quadratics in the denominator, it can get super messy. And people always go, oh yeah, my teacher told me to do cross multiply, and I'm like, okay, great, but guess what? You're gonna have problems later on. Anyway, did that picture load up? Yes, it did. This is what do you call that question? Kinematics. There we go, kinematics. Cool. So a car is traveling at 30 miles, signal to stop by police officer. When the driver applies, it decelerates at 2. Okay. So here's with kinematics. Who sent this? Stacy. Kinematics. What you got to do is you got to kind of like you got to put down all the information. But more importantly, I'm not gonna lie, and this is probably very old school, but it still works. I like to draw diagrams for kinematics. All right, I don't ask me why, but it makes sense for me when I actually draw a picture of it. All right, so that's what we're gonna do right now. I'm gonna draw a car. There's my beautiful car. Okay, so what's happening to this car? The car is traveling at 30 meters per second. Okay, so this right now is 30 meters per second. So at this point, I'm gonna call this t equals to 0. All right, because I don't have any information beyond this particular moment. At this moment, when the signalman, the police officer is signaling to stop, I'm going to put that as t equals to 0. And the speed is at 30. All right? This is a key important bit of information. Now, we also know that the car is decelerating at -2. So we got to try and figure out for how long does it take him to stop. So basically, if you think about it like this, his velocity right now is 30. We want to know when is the velocity equal to 0. We have the formula for acceleration, and if you guys have been doing integration, you know that when you anti-differentiate or integrate acceleration, you get to velocity. So I'm going to go here and I'm going to put acceleration as -2, which means velocity equals -2t. And of course, I have to put the plus c. All right, I got to put plus c. It doesn't matter. Whenever you integrate, you got to put plus c. So I've done that. But I've got to figure out what the c is. And to figure out what c is, I've got to use the first bit of information, which is this right here. When t equals to 0, velocity equals to 30. So when t equals to 0, velocity equals to 30. So I can put this in here. 30 equals to -2 times 0 plus c. -2 times 0 is 0, so c is equal to 30. So in other words, this equation for the velocity is -2t plus 30. And if you look at our question is actually asking how long does it take him to stop. For him to stop, the velocity has to be 0. So we put velocity equals to 0, and we go -2t plus 30. Rearrange. -2t, when it comes to this side, it's going to become +2t equals 30, and then t equals 30 over 2, so t is equal to 15 seconds. Why is it -15, King Gamer? Did I make a mistake? I know what you did, man. You got to be careful with that, because remember, it's -2 times 0, which is 0 itself. Nah, it's all good. Stacy, were you okay with that part there? Because, or if anybody else has a question about that part, just let me know, and then I can move on to the second part of the question. Cool. So the next question is like, how far does he travel between the time he applies his brakes and the time he stops? What this time they're asking is, when he stops, so t is equal to 15, they want to know what s is. So that's like the distance, right? Now, we also know when t is equal to 0, because that's when we are starting to measure his distance from. So he is braking his car when t is equal to 0. He, she doesn't, well, yeah, he. So that means after 15 seconds, he's actually traveled a set of distance. So what we know is, we know a velocity formula, which is negative 2t plus 30. So we know our distance formula, because we just got to integrate again. So negative 2t, now this is going to become squared over 2, which is the new power, plus 30t plus c. But here's the thing. When t is equal to 0, we know that s is equal to 0. So then we can kind of say that s is 0, so you're going to get 0 equals minus 2 times 0 squared over 2 plus 30 times 0 plus c. And we can kind of see that c is equal to 0. All right? So our distance formula is equal to negative 2t squared over 2 plus 30t. Or we can just rewrite it as negative t squared plus 30t. Now, our time when the velocity is equal to 0, so that's when the car comes to a stop, is after 15 seconds. So we put 15 in here. We're going to get minus 15 squared plus 30 times 15, whatever that is. Let's go work it out. So minus bracket 15 squared plus 30 times 15. So this gives us 225. I guess this is going to be, the answer is going to be 225 meters. One question, so in part A, why do we make t equals to 0 when b is 30? So remember, like the initial part of the question, like right at the beginning, the question actually says car is traveling at 30, is signaled to be stopped by a police officer. So that's what I mean by like at that particular point, we're going to put the time is equal to 0. So that's the moment when the police officer actually said, right, you need to stop the car. So that's why we know the velocity is 30, but at that moment, velocity is 30. So we're going to go, that's the time we're going to start our time from. We don't care what's happening before that, right? We don't actually know what's happening before t equals to 0, because we don't know what his speed before 0 was. It could be more, it could be less, we don't know. But what we do know is that there was a moment when the policeman asked the car to stop, and that's the moment we're going to say t is equal to 0. So that's why t is equal to 0 and velocity equals 30. Now sometimes you might see things like they use the words like initial, at the beginning, at the start, like, yeah, little words that they use, which generally means that t is actually equal to 0. Right, Malika, I know you sent me a couple of questions, but I did say I was only going to be here for an hour. I'll have a look at, where is it? Is it something I can do quickly? Accept primary, move that to that. Number 4. Okay, Malika, what I will do is question 9, 10. Man, I hate these questions that come upside down on this. Okay, what I'll do is I'll give you a quick little tip about that, right? I think I looked at all sketching. Number 7, oh yeah, okay, cool. So here's a little tip for you, Malika, all right? So I'm gonna do this, and it's a really good kind of idea for you, right? So if you actually have like, when you have a cubic, All right, so let's say you have a cubic. Your cubic actually could look like this. So that's your positive cubic and your negative cubic. So I'm going to put down positive, negative cubic. When you differentiate a positive cubic, it's going to be a positive. So this is like x cubed. This is like 3x squared. This is like minus x cubed, minus 3x squared, which means it's going to be a parabola that looks like this. When you differentiate a parabola, you get a straight line. So this is going to be positive straight line, which is 3x. And this is going to be negative straight line. So just to give you a bit of a hint on this, when you differentiate, this is the direction you're going for differentiation. When you integrate, you're going the opposite direction. So I think if you have a look at the questions you sent me, Malika, it's like some of them are just asking some really basic questions, like what happens if you have a cubic and you differentiate it. Yeah, like, so if you have a cubic, when you derive it, it's going to be a parabola. When you derive a parabola, you're going to end up with a straight line and so on. Right, guys, I'm going to kind of leave it at that for now. So I'm going to try and organize another Q&A session if you guys want it. Otherwise, I will probably move on to level ones. So just give me, I'll probably put a little notification for next one just to see which one is popular, and probably run that on, when is it? Thursday. I'll be doing it Thursday next. All right. So just keep an eye on Instagram so you can kind of, what do you call it, vote for which tutorial you want, and then we can actually go from that. King Gamer, I'm supposed to be working on an optimization video. I might actually do it tomorrow, man, because that is literally my, my next topic. I've got to do an optimization, like a whole series of videos for it. And then after that, I'll go into integration. So that'll be there. Coming soon, I promise. Just can only do so many things in one day. All right, guys, I'll leave you guys with that. If you do have any questions, I'll hang around for like a couple of minutes, just to not to do actual questions, but other things that I can kind of answer. If not, have a good night, and I'll catch you next time. Yeah, no worries. See you later, King Gamer. And yeah, and look, keep an eye on Instagram about when these next sessions are going to be. So I'm going to try and run like 2 a week. And as we get closer to the exam, I'll try and push it up to 3. Just trying to kind of like manage my own time as well. Keyboard smash guy. Why? Yeah, I think I do, Stacy. I don't know why. It's like you meet people and it's like you kind of just remember names, and then now I'm starting to meet people outside of the streams, which is really cool. Like I met a student last term who's like a 3rd year engineering student, and she was telling me like she was using some of my stuff back in the day, and it's just kind of cool to meet people for a change instead of just talking to myself in front of a screen. Good times. All right, guys, I am out now. Catch you later. Till the next time, yeah? Take care.